There we go.
We are live now and broadcasting on YouTube. So we can use your screen share using StreamYard. So yeah, just a quick introduction before we begin. Hi Jordan. I'm Prashanti. I'm working with JP Morgan as a technical business analyst, and I'm one of the organizers at GDG Glasgow. It's very good to have you here with us today. So I'll give the stage over to you. Yeah, please feel free
Yeah.
to introduce yourself, and then we can kickstart.
Yeah, thanks for having me here today. My name's Jordan, and I'm an associate software developer in the customer experience engineering team at Charles River. I've been working on tutors for around a year and a half, and I'm happy to present it here for everybody today. So let's get going. So today I will be talking about empowering remote education with the Tutors open source project. Again, my name's Jordan. I'm an associate software developer at Charles River, and I've worked on tutors for around a year and a half, alongside attending SETU Waterford as a HDIP in computer science student. We're going to start today's talk by talking about EdTech, or educational technology, and how Tutors aims to unbundle the EdTech space. So this is the way most of you probably learned computer science, in a lecture hall, taking notes off a slide deck, writing Java methods on paper. Tutors aims to provide a more modern learning environment, i.e. one that can be delivered remotely, which can integrate well with and learn from traditional learning practices. There's quite a large selection of learning platforms and courseware providers in the EdTech space, many of which most of you have probably never heard of, but one that we've all grew to know and love is Moodle, the learning management system. I'm sure most of you have used it in college. It's a one-stop shop. It's a jack of all trades, master of none. And as much as it aims to please, and it's been a great contribution to EdTech, it uses old technologies out of the box. Think MSN Messenger style chat features. Most students these days weren't even born when MSN Messenger was around. So of course they expect more modern solutions. Also, how would it handle live online classes, real-time chat communications, and document collaboration? This is where Tutors steps in. So the motivation for Tutors is to improve the learner and the educator experience, to provide MOOC, or massive open online course quality delivery, that is open, free, and low cost. It looks to provide a framework for blended online learning and delivery, BOLD. It looks to unbundle the learning management system using a coherent toolset for teaching online. And that's where Tutors Stack steps in. A 4-layer coherent toolset for teaching online, which has been invented by SETU in response to their experience with Moodle and learning management systems. And it aims to unbundle or separate the main functions into 4 layers. This toolset lets you swap in more suitable alternatives as they become available. So the Tutors Stack is broken down into 4 layers. These layers are learning and instruction materials, communications and community, assessment and feedback, and media management and streaming. As part of the stack, we've created Tutors, an open source platform which enables lecturers to structure and publish rich learning materials much more easily than other platforms. This is the layer of the stack that we'll be focusing on today. The other layers of this stack have recommended platforms that are tried and tested through the HDIP in Computer Science pilot program, which I'm on. And these are Slack and Zoom for communications, and Moodle and Socrative for assessment and feedback, and YouTube and Zoom for media management and streaming using the OBS and ScreenBrush software. So this brings us on to Tutors as a software. Tutors is an open web learning toolkit which provides 3 complementary perspectives. And we're going to look at each of these perspectives in depth over the next 30 minutes or so. The 3 perspectives are the learner experience, the educator experience, and the developer experience. We'll begin today with the learner experience. The learner experience aims to prioritize web interactions that are engaging, so it should be visual and stimulating and provoke a sense of exploration in the learner. It should be contextual, with suitable navigation features to be able to visually explore learning objects in appropriate contexts, and schedule-oriented indicators and selected external services. Transitions and animations are also used to subtly enhance the contextual awareness. All things should be linkable, meaning they should be capable of being bookmarked or shared between learners or between learner and educator. It should be searchable, supporting full text search and filter or summary views. And it's accessible, supporting accessibility where possible, currently including dyslexia, colorblindness, and visual impairment. And it's responsive, so it should adapt adequately to the full range of device characteristics and orientations, from mobile phones to widescreen workstations and across multiple operating systems. In addition, the experience should foster a sense of community and connection among learners, letting learners optionally share their presence and activity as appropriate, and view and communicate with other online classmates easily. So this is what Tutors looks like when you open a program homepage. It has a simplified navigation bar at the top, and each semester here is broken down into cards. These cards then link to individual module homepages for that semester. And then this brings us into the course homepage for that module. This again is broken down into cards and has a more useful and contextual navbar on the program than on the program homepage. And we'll just quickly break down the navbar. So along the top, we have the primary and secondary navbar. On the left, we have the course info with an icon, title, and course credits. In the middle, we have a course calendar with the current week and a button to open a sidebar, which displays the calendar along with the current week being highlighted that you're on, so you know whereabouts you are on the course and when the course finishes. Then we have a search button on the right to be able to search course content. There's a layout menu, which when pressed opens some toggles, for example, being able to toggle dark mode, a compact mode, and select one of our custom themes. Then on a course which has login enabled and a user is logged in, their GitHub avatar will be shown in the top right, along with a tick for their present status, green for online and red for offline, and a number of users online at the current time. If they press on their avatar, a drop-down opens with some more contextual info, such as being able to toggle their presence and open a sidebar to see who of their classmates is online, what their classmates are currently studying, and they can then search for their classmates on Slack and send them a message if they're looking to study together. There's also a table of contents button, so you can open a sidebar with an accordion drop-down, and you can easily drill through the course without having to click through multiple cards. Then in the secondary navbar, we have a breadcrumb nav, so you know where you are on your course. And on the right, we have companions and the wall, we have called them. So the companions is educator provided, and this has things like links to a Slack channel, a Teams channel, the Moodle homepage, and a YouTube playlist. And then there is the wall section, which links to pages that just display videos, talks, labs, and downloadable archives. Then the topics on the course homepage have a card for each week or topic. And then when you click on one of these cards, this brings you into the single topic view. The single topic view at the top has a topic video, which can either be pre-recorded and uploaded to your favorite video upload service, such as YouTube, Vimeo, HEANet, or it can be a YouTube live stream. And the advantages of YouTube live stream is that it can be embedded directly in the page here. And if a learner misses a live lecture, they can come and play it back on YouTube here, and it can be played back with different speeds and with subtitles, etc. Underneath the topic video then is each of these subtopics, and this is broken down into cards again with links to the talk slide PDFs, to the labs, to archives, etc. And if the talk slides have a single video, there is a video icon in the top right of the card. The talk view then shows a slide deck, which is a PDF of the slides, And this can be navigated at the top right with going back and forth, being able to rotate, download, or make the slides full screen. And on the right of this, we have a topic navigator, which shows a contextual list of talks and labs in the topic that you're working on and allows the learner to navigate through the topic without having to go back to the home page. And then labs. Labs are like you do in college. So you go to a lecture and the lab is exercises for you to follow along to be able to get contextual info and learn what you are doing. So in this demo here on the screen, this lab is a simple Svelte to-do app. On the left, you can see the lab steps navigator to be able to click through the steps. And on the right is the content for each of the steps of the lab, including a code block and images. To give you a more concise demo, let's break down and go into a live demo now. So here we can see the High Diploma in Computer Science course. This is the course that I'm currently studying, and this is on tutors. So here, this is the course homepage. We have each of the semesters broken down into cards here. And if we click into one of these cards, it will bring us to that module. Now, this course has authentication enabled. So if we try and go into here now, it will ask me to log in. So I can click sign in with GitHub. This may take a second. It gets an access token, and that brings us back to the course then as a logged in user. And then it gives us a little pop-up about tutors' time. We probably won't have time today to be able to talk about tutors' time, but this is the metrics service that tutors have created for educators to be able to see if a student has worked on any of their content. So we can press proceed to course. And here we are logged in. We can see my GitHub avatar here at the top right. And if I click this, we can see I can toggle my presence with other learners, and I can open the sidebar to see who is online. Along with this, we can change our layout. So the dark mode toggle, the compact mode toggle, and choose our theme between the tutors theme or dyslexia theme, which has a more yellow background for easier reading and uses the open dyslexic font to ground the text to make it easier to read. Then we can go into each of the topics here. So I can go into the Svelte introduction topic. And this has the topic video at the top, which we can play. This was a live lecture, and you can then go through and turn on subtitles, change the playback speed. And underneath this, we have each of the units. So we have the Svelte introduction unit and the to do in Svelte unit. I can go in here to one of the cards, and this will bring me to the talk. I can navigate the talk. And on the right here, I can also go to the single video just for that talk. Then we can go into the lab after we've watched the content, and we can follow along the steps of what needs to be done for the lab. We can also go into the search feature. So for this, we will just search test, but if we click search, it'll bring us to a page. And if I type test, here we can see it instantly gives us a response for what I've searched for. We can go and find what we need, and we can click the link, and it'll bring us to that page. Although it does have to render the whole course when you click the link, so it may take a second. And that is all for the learner experience. So let's move on to the educator experience. The educator experience prioritizes the creation of guided paths through a curriculum via the creation of learning materials that are autonomous, so capable of being hosted anywhere with or without the use of tutors' cloud services. Structurally aligned, so the structure of the learning content should mirror the structure of the guided learning path. Composable, allowing the educator to easily construct courses from elements of other courses and combine courses into programs. They should be auditable, making it possible to ascertain whether students have engaged with specific learning resources. That's where tutors' time steps in. It should be extensible, being possible to introduce new parallel learning services within a family of tutors' tools. And it should be able to be versioned, making it possible to place a course under Git-based version control, supporting rollback, branch previews, and other version management conveniences. And it should be independent, so it should be possible for an educator to migrate away from the tutor's ecosystem to comparable systems if they wish. So modules for tutors are structured in a simple manner. A module consists of a topic consists of units, and units are broken down into notes, videos, talks and presentations, labs, and downloadable archive. A module is created on an educator's local system following a logical folder structure using markdown files, images, and PDF slides, which can then be backed up and version controlled via Git. The example that we'll be talking through in this section is available at the reference.tutors.dev link here. So you can go through and click through this while I talk if you so wish. So topics are structured using semantic naming conventions, as we can see here. So we have topic 1, topic 2, topic 3, and topic 4. Inside these, we have book A, we have talk 1 and 2, etc. The single topic structure then reflects the structure of what is in the single topic view. So the root folder of the topic contains 2 files, as you can see at the bottom, indicated by the orange arrow. The topic.md file, which has the topic title and description, and the topic.png file, which can be any image file really, which is the topic card image and the header image up here. This can also be an icon using the Iconify icon sets. Each folder is there for a unit. So in this case, we have unit 1 and unit 2. Unit 1 here, as you can see by the red arrow, has a panel video, which has the panel video markdown file and the YouTube video ID. And unit 2 down at the bottom has more rich content, such as notes, archives, and web links. And for time's sake today, we're just going to look at talks and lab structures. And if you're interested in finding out more, you can take a look at the reference project source code. The GitHub for the project is at the end of this. So the talk folder contains 3 files. The markdown file containing the title and description, the PDF file of the presentation, and the PNG or image file, which is shown on the card of the talk. And then labs are structured by using one semantically named markdown file for each lab step. So as we can see here on the left, we have 00, 01, 02, and each of these reflects the lab steps and on the left at the top. These labs support a wide range of markdown content using the Showdown plugin. As we can see here on the right, this has a code block, and it also supports KTeX math, images, and tables. And then there's 2 ways for an educator to publish a module to be consumed. This is dynamic or JSON publishing and static or HTML publishing. We'll start by talking about dynamic publishing. So dynamic publishing is a dynamic site that is browsed through the Tutor's Reader application. The advantage of this is the Tutor's Reader application is continuously updated and enhanced with new features, and it also includes optional analytics or presence features. Dynamic or JSON publishing is done by running the npx tutors JSON command in the folder that you created the course, and this runs the tutors JSON command line application. This app generates a JSON folder to be consumed by the tutor's course reader, and we will break down the architecture of this application in the developer experience section. So to be consumed by the course reader, the course has to be deployed. As Tutors has been given a Netlify open source license, we use Netlify for deployment. And the 2 ways to to deploy the course is either uploading the course to GitHub and then deploying using GitHub deploy on Netlify. And the advantage of this is it allows auto deployment on version changes. So if you push to GitHub, it will deploy that new version. Or you can manually run the tutors JSON and drag and drop the JSON folder to Netlify. Either of these deploys the JSON files to a link, which can then be consumed by the course reader. The other method of publication that Tutors supports is a static or HTML site. This method generates a static website that can be browsed offline by either distributing a zipped archive to the learner or being uploaded to what we would call a traditional web host. The downsides to this form of publication is the format of the course is frozen at the time of generation. So the layout and the design will not change with Tutors version updates. And this form of publishing has no analytics or presence features, which comes with the course reader. Static or HTML publishing is done by running the npx tutors HTML command in the folder. So the first is tutors JSON, this is tutors HTML, and this runs the HTML command line application. This app will generate a public site folder, as you can see on the right, which can be distributed by sending a zip file or being uploaded again to a traditional web host. And then let's dive into the developer experience, the nitty-gritty behind Tutors. The developer experience prioritizes the spec and implementation of robust, well-documented, loosely coupled components and services that is integrated into a coherent toolset, and it should be open to contributions from many diverse skill sets. So before I overload you with information, let's look at the origins of Tutors. Tutors as a project is not new. It began around 10 years ago as a Bash and then soon a Python application with extremely similar principles as it had today. It would ingest Markdown content, as it still does, and it would generate either a zip file that could be uploaded to Moodle as a lab or a static website. So the screenshot that you see here is actually of a course from 2013 with an early version of Tutors. And then here we can see that's been upgraded. This is a 2015 course using Tutors. And then moving on to 2019, we can see a bit more of a nicer user experience coming along. And now here we are in 2022. And this is the latest version of the Tutors course reader that I published last week. So let's dive into the architecture or the tech stack of Tutors. Tutors is open source from day one. I'm sure if you go digging through our GitHub profiles, you will find some very old versions of Tutors that don't look very pretty. But the current version of Tutors is built in a mono repo with turbo repo for better self-dependencies and build runtimes. Tutors embraces the Jamstack, Jamstack being JavaScript API and markup stack. It has command line applications and single page applications built upon Node.js. And the sites are built with TypeScript, Vite, Svelte, Astro, Tailwind, and Skeleton UI. User publishing is done using GitHub Bitbucket or Netlify's drag and drop feature recently. Firebase and Auth0 is also used for some features of the reader, such as login and presence. And Tutors has been granted a Netlify open source license, so Netlify is used for our deployments. There's 4 major subsystems in the Tutors ecosystem. This is courses, apps, sites, and components. Courses are built by educators. There's currently a couple of hundred courses or modules being actively ran through Tutors at this stage. Apps are the command line apps for generating courses. Sites are the web apps, so apps for reading the courses, the presence and time functionality, and the Tutors website or homepage. And components is a shared TypeScript component library for apps and sites. Our monorepo then mirrors this architecture. all components are embodied into the one monorepo and broken down into folders containing the relevant elements. So this is how the architecture looks when we look into it. We have some test or reference courses in the repo, which can be used as a reference by an educator to build a tutor's course, although the courses themselves are managed by the educator. The command line apps then at the top are tutors JSON and tutors HTML, which generate the dynamic or the static version of the courses. The web apps then are the course reader, which we had a demo of earlier in the learner experience. There is tutors time and the tutors analytics service, along with the homepage or website of tutors. Reader and tutors time are both Svelte applications, and the homepage is built with Astro. Both the command line applications and the web apps then depend on the components as seen here. So this is the tutors lib, tutors configs, the reader lib, and the UI library, and we'll talk more about these soon. But first, we'll dive into the architecture of the generators, which is tutors HTML and tutors JSON. The generators are node apps, which depend on a common library, the tutors lib, and these run and transform a folder or course into a version which can be browsed by the course reader or generate the standalone HTML website. We will start by looking at tutors JSON. So tutors JSON transforms the course by emitting an exact copy of all the assets, maintaining the same structure of the course, but it encapsulates the deep structure into the tutors JSON file. That JSON file is effectively a serialized version of the structure of the course itself. That course is built up by the tutors lib parser as what is effectively an abstract syntax tree. And it's a bit like how a compiler works, but instead of compiling a single file of a formal language, we're trying to compile an entire folder structure into an in-memory model. So courses are learning objects. A course contains topics. These topics are also learning objects. These topics contains talks, videos, notes, archives, and labs, and a lab contains chapters. That's the deep structure of the model that is developed and assembled in memory by the tutors lib library. The JSON emitter then is traversing the tree, emitting out into the JSON file all the learning objects that it encounters. So the emitter structure is basically emitting courses, topics, videos, archives, and so on. It's a fairly short TypeScript library. It's only around 150 lines or so, but it traverses the entire tree and produces a representation into a single JSON file. Moving on to static site generator then, tutors HTML, and it implements a very similar structure. It takes the course and provides the same copy of the assets, except this time each folder is decorated with HTML static versions of the course. And it has a similar structure to how the JSON emitter works, but HTML is a little more complex as it has to embody all of the styles associated with the page. So to do this, it uses the Nunjux templating language, and it's currently using an old variety of styling from a previous course reader version using Tailwind and Daisy UI. It's in the pipeline for this to be upgraded. Again, the HTML emitter emits courses, topics, learning objects, units, etc., using the same syntax tree the JSON emitter is using, except this time it generates much more content as it has to generate the user experience as a static standalone site. So that's the basic structure of the apps, the two emitters, the JSON and HTML emitters. The HTML emitter is function complete, but it doesn't include a range of features that the course reader has, such as the authentication, presence, metrics, and an overall more compelling user experience. The tutor's HTML emitter is often looked at as an archive, whereas an educator provides the standalone version of the course content to the students after a semester is finished. So let's move on to the front end, and in particular, the tutor's course reader. The tutor's course reader is a Svelte application which consumes the JSON output of tutor's JSON and renders a course, providing a compelling user experience for the learner. It relies on two components: tutor's UI, a reusable set of UI components that's responsible for rendering the core elements, the learning objects, and tutor's reader lib, which is a TypeScript library which is responsible for loading the course from the remote server, along with starting up and driving the analytics, metrics, and presence models. So looking at the reader is a Svelte application that has two major packages, the navigators and the pages. And the pages correspond more or less to the learning objects on the abstract syntax tree. Course, topic, lab, video, each of these pages render out the learning experience from that learning object to the canvas. The tutor's UI component library then uses the atomic design methodology, which breaks down the user experience elements into atoms, molecules, and organisms. We also plug in themes here for the design, which is a CSS file. In here, you may recognize some tutor's learning objects. So in the cards folder, we have some cards for notes, talks, and videos. These are all fairly independent components, which are assembled then into the user experience of the reader. The reader lib then is where a lot of the heavy lifting is done in downloading the course from the remote service and building up in browser a memory model for the course. So that's why it took a while to load the search earlier. We have got course, lab, topics, and other types, which are derived from the abstract syntax tree for a course. And we also have a collection of services. So the course service, which is responsible for caching the course, auth service for authentication via Auth0, currently supporting GitHub authentication, analytics and presence services, which are monitoring interaction with the course and making that available to educators, and the presence service allowing students to see who else is online and what they are doing, provided the student is opted in by ticking the Share Presence button. There's also some classic Svelte stores and a range of types and utilities here. The models package has a slightly more sophisticated version of the abstract syntax tree that's equipped with some caching and indexing, and also we need to ensure all elements are linkable, so it needs to generate URLs to be shared. All of that simplifies the hydration of the course within the reader. The services is about the intelligence, as we call it, so it reads and initializes each of the subsystems. So this is the overall architecture. If we look at it in one piece, we're trying to keep it reasonably coherent with reasonable readable package names, so the architecture can easily be navigated by the developer. And here's how the architecture is packaged, with the course reader on the left being the front-end Svelte application, and on the right, the two relying packages, tutor's UI and tutor's reader lib. And then this has the turbo repo, monorepo, ensuring that these are built effectively. And here we can see a couple of screenshots of the folder structure of the overall archives. And then we're back to the beginning. So this is the structure of the tutor's monorepo as a whole. So I know that was a lot of information to take in. Let's step back a little bit and take a look at a case study. The pilot program that uses tutors for remote delivery, the SETU HDIP in computer science, a 2-year part-time program delivered by SETU Waterford, which uses tutors. It's the first full program delivered remotely by SETU. The higher diploma in computer science is a 24-month, 90-credit level 8 IT conversion course that is 90% funded by the Government of Ireland for IT Irish residents. Using the tutors stack, the course won the Best Use of Educational Technology and ICT Initiative of the Year in 2020. So the final year of the program being delivered face-to-face was 2017, and the applicants were surveyed regarding their preference of delivery mode. And a staggering 88.9% of those surveyed indicated preference to take the program fully online. So the course itself is delivered in agile semesters, typically consisting of 4 3-week sprints, followed by 1-week breaks for retrospective after each sprint. This reflects the agile methodology that is used in software development. The philosophy was developed with contributions from Red Hat, and it has been published in the Industry Practices, Processes and Techniques Adopted in Education book, and this was only published this year. This method of course delivery has led to 87% of students completing all classes in semester 1, with a course retention of 80% versus Ireland's national average of just 55%. It also provides learners with the transversal skill of remote learning and working, and it's been doing this even before the pandemic. So this is what a few past students of the course have had to say about the course delivery online using tutors. So I'll read through them. The course has allowed me to undertake my studies with great flexibility in such a way that standard face-to-face course could not. I've been impressed by the methods of delivering the online lectures and the step-by-step content for the accompanying lab work and adopting the latest technologies. There's plenty of flexibility in the online delivery, which is a game changer if you're a busy professional or self-employed. And I didn't feel any disconnects from classmates or faculty members by doing the course online. As you can see, the move to tutors has been a success for the program and has been extremely well received and has been adopted by over 200 modules at present. Fully online delivery gives more students the flexibility required to study programs that they otherwise couldn't. The package of initiatives described in the previous sections elevates the student experience above traditional, blended, and some existing online delivery approaches. And finally, a roadmap for further development. Currently planned for development in tutors is the creation of a new quiz learning object, upgraded command line designs for the generators, upgrading the HTML generator to a new design system, the creation of an Astro generator, and the implementation of new graphing features for the time reader, which we did not get time to demo today. And these are all published as issues on the tutors GitHub repo. I'd like to thank you all for coming to my talk today. I know, again, that was a lot of information to take in, but if you're interested in finding out more about tutors, either to use for education or to contribute to the tutors open source project, please feel free to reach out. Our website, GitHub, Twitter, Mastodon, Discord server, and my email is on screen. Do we have any questions?
Hey, like, thanks a lot for the wonderful session, sir. Actually, like, we have a question from multiple audience who have joined from here. Like, for example, if you're working onto a large scale project and there are the multiple nodes that are associated with it, while we have like multiple packages, so what would be the most effective way to manage them at the right?
If it's one large-scale project with multiple packages, we have moved to the Turbo repo monorepo. Turbo repo is built by Vercel, and it allows dependencies within your own project, so you wouldn't have to be publishing to NPM every time there's a version change. We found this move very effective.
All right, like thanks a lot. Like as well as like there was one more question from the people. That like okay, so like for example, if we have multiple SDK that is like associated with to a single, like whenever like we are like like when we are like dealing with a multi-threading within the same system. So like is there any specific approach that we should follow throughout in order to like make the whole process more optimized?
Gosh, that's a question. It just depends on what you're doing. You'd have to go and research what you're doing and what would be the best approach for the language that you're taking. Like for example, we're using Svelte, so the best approach for us might be different than the approach that you're using, whether you're building web apps, whether you're building mobile apps. I couldn't give one solid answer to that question.
Yeah, thanks a lot.
Yeah, no worries. Thanks again for having me here.
Thanks, Jordan. It's been a wonderful session. So I just saw the YouTube viewers keep increasing. You please feel free to share this with all your friends, and we have this recorded and live streamed on YouTube. I'm sure a lot of us can benefit from this offline as well, not just the people who have attended this right now. So thank you so much once again for being a part of Google Developer Group, our speakers this DevFest 2022, and we look forward to having you again.
Yeah, thanks, Million Prashanti. It was good to be here.
Yeah,
Thanks,
thank you
everybody.
so much. Have a good day.
Bye.
Thanks. Bye bye.